Today, we'll talk about chapter 2, where we'll talk about the fractions. I'm sure that most of you have been exposed to fractions, right? So most of the content in this chapter may be a refresher, or maybe some of the contents may be a little bit new to you. Again, we know the whole numbers, right? And we know that the whole numbers can be divided as well, just like every other number, every other types of number. Now, if you divide the whole number into different parts, those are actually becomes the fraction of the whole number, right? And when you divide it, you get a fraction, and in the fraction you have actually two numbers, okay? There is a horizontal line, and there is a number you have at the top, and there is number you have at the bottom. The number you have at the bottom, that is called denominator. Number you have at the top, that is called numerator, right? Now, actually here, the denominator actually shows that how many parts you will have for that whole number, right? And the numerator actually shows the whole number that is being divided, right? Now, for an example, let's say you have a whole number like this one. This is just 1, right? And when you try to make it divided by 2, it becomes halves. Now, when you have halves, you write 1/2 as like this, right? Now, if you look at this one, the first number here, which is 1, is your numerator, which is the number being divided. And the second number, which is 2, that is basically telling you how many parts you are getting, right? Because you are basically dividing the whole number 1 into 2, and that's why you get 2 different halves. Similarly, this is fourths, meaning like quarters. This is 1/8. And in every type you see that we are dividing and we are getting like equal parts, right? For an example, the last one, we are dividing 1 by 16. The 1 is a whole number, and 16 is the number which tells that how many division we have. And each of the division is actually 1/16 of the original number. And each of the division, which is, these small parts, are actually equals. They're each other, they're equal, okay, when you divide. So let's look at some of the quiz questions here. Now, for the fraction 3/4, which one is the numerator? 3, right? Okay, right answer is A. Which one is denominator? Of course, 4, the bottom one, right? So the right answer is 4. Let's look at an example here. Before serving this is a word problem. Before serving our pizza at the party, I divided up the pizza into 12 equal pieces. I then ate 3 slices of pizza. How many of pizza did I eat actually? Okay. Now, think about the original pizza that is actually one complete pizza, right? And each of the part, meaning how many initial division you had. You divided the whole pizza into 12 at the beginning, because each slices are, there are 12 slices, right? And those are equal slices. So actually one of the slices is 1/12, right? Since you divided the pizza into 12 slices. Then I ate 3 of the slice. So is actually I'm doing this, because I took 1/12 3 times, because I ate, that many. And then that you can write 3/12, okay? Now, if that is the case, so your right answer should be B, right? Which is 3/12 of the whole pizza. Because each of the equal slice was 1/12, and you ate 3, right? Any question here? So actually the right answer is B, okay, which is also equal 1/4 of the pizza. Okay, we'll show you how we simplify the fraction. Okay, meaning how we get 3/12 to 1/4. We'll show you here. Okay. Now again another example. Word problem. I bought a bag of apples that contained 20 apples, and I used 15 apples for a cobbler. What fraction of the bag did I use for the cobbler? Now again, total I had 20, right? So what fraction of the apples? So meaning you want to know the fraction. So this is the total, and that's what you used, right? So actually you have used 15/20 fraction, okay? Meaning 3/4 of the bag for a cobbler, okay? Now, here are some whole numbers, right? We all know the whole numbers. We see the whole numbers every day. These are some numbers which has a whole number and a fraction combined, okay, together. Let's say this one is what? 4/2, 8 2/3, 6 10/4. These numbers are called mixed numbers because they are neither whole number, they are neither fraction, because they have both parts. They have both whole number, they have both fraction, okay? Now, we are just looking at some of the terminologies, okay? Some of the definitions of different types of fractions, and also fractions and whole numbers. We just saw it, right? Now, in case of the fraction, so far we know that in the fraction we have two numbers, one at the top and one at the bottom. The one that we have at the top, that is called numerator, bottom one is called denominator. Now, if the denominator is smaller, I'm saying numerator is smaller than denominator, like here, okay? Look at this one. In each of these examples, your numerator, meaning the number you have at the top, is actually smaller than the bottom one. These are called proper fraction. In the other case, where our numerator is greater than denominators, those are called improper fraction. And all the improper fractions has value greater than 1 actually, okay? And in case of all the proper fraction, each of the fraction, no matter how you write it, whatever the the numerator or denominators are, they will be always smaller than 1, okay? 1 means 1 is a whole number, right? So they're always smaller than 1. And the improper fraction, they are always greater than 1. They might be even greater than 2, they might be even greater than 3, but they must be at least greater than 1. Now let's look at an example here. Now what type of number is this? It's a mixed number, right? Because we have a whole part, we have a fraction part. So the right answer is B. Again, it's a whole number, right? That's just a whole number, right? No fraction. Proper fraction, right? Improper fraction because the numerator is greater than denominator. Now let's try to see the numbers with the scale. Let's say we have a scale here, okay? Now, or the ruler. Now in the ruler, we can always, just like the whole numbers, we can also find the fractions. They represent the same thing. Now for an example, let's say we have 2/3. That means you are dividing 3 inch by 2, for an example. Let's say you start from here, you go all the way up to here, which is 3, right? Now if you divide the 3 by 2, that becomes, you are basically here, right? So you are talking about from 0 to this point. So I'm talking about from 0 to 3, right? If you talk about 0 to 3 and you divide it into half, you go all the way up to here, right? So pretty much you are talking about this half, right? Similarly, if you take 6 inch and divide it by 4, now 6 inch is what? Up to here, right? And you divide it by 4. If you look at this one, if you divide it by half, you will get where? Here, right? You divide it again half, you will come here. So it's pretty much the same thing. So if you divide 3 by 2 or 6 by 4, or even if you write 1/2, now 1/2 means what? You go up to here to make it 1, and then you go another half. So technically all of these are same. So that means that even if they look different, a lot of the fractions look different, because the first twos are the fractions. This is 3/2, which is an improper fraction. The next one is 6/4, which is again an improper fraction. The last one is a mixed number, 1/2, but all of these are actually same in the ruler. Okay? So that means even if different fractions look different, they are actually same. Okay? And we'll know soon that how we can identify such fractions, and we can tell whether they're same or not. Okay? Let's look at some quick reading from the ruler. Can we read how much it is? Look at this. We came all the way up to 2, right? And then this is what? This is 2/2. 3/4, right? Because you are dividing the next one by, because this is 3 parts, right? Because you have 1, 2, 3, 4 parts together to go to 3. So actually the right answer is C. 2 3/4, right? Because you go all the way up to through here, and this is the 3/4 of the next one, meaning between 2 to 3. So the right answer is C. Let's look at another example. Now we are still reading the same thing, but instead of reading it like the way we did before, we can do in a different manner. Okay? How can we do it? Okay, just to make it simple, because I'm not explaining here, because I'll explain in the next slide. The right answer will be 11/4. Now how? Because as I said, remember I said that you can write fraction in different manner, right? Now let's look at y. See, all the mixed numbers, okay, can be converted into an improper fraction. Okay? How? For an example, let's say we have a mixed number here, right? 3/5. So what you need to do is you multiply this whole number, which is 4, times this denominator, okay, and add the numerator. So this is exactly what we are doing. Okay, we are just multiplying the numerator, whole number. This is the whole number, right? Times the numerator, which is 5, to make it 20, and then I add whatever I have as the numerator, and that will be which is 23, right? And now the 23 will be your new numerator, and denominator remains same. Okay, and now this new fraction is what? 23/5. So this 23/5 is an improper fraction, which is actually equivalent to the mixed number we have before. Okay, let's look at a couple of. So we can also do the backward. So let's say we have the improper fraction. We can also write the mixed number. How? For an example here, let's say you have 27/5, right? And you are trying to get, this is an improper fraction. So what you do is you divide 27 by 5, okay? Just like a third grader. So it's 5 times 5, you write 25, right? And you have a remainder of 2. So then, this is how you do it. So your quotient, this is your quotient, right? when you do the division, 5 is your quotient and 2 is your remainder. So your quotient goes as a whole number, okay, and your divisor becomes the denominator, and the remainder you have becomes numerator. Okay, that's how you will get the same number as a mixed number. So that means if you have an improper fraction, you can always convert it to a mixed number. Okay. Any question here? And similarly, if you have a mixed number, you can always convert it to improper fraction, right? Let's look at a couple of examples. Now let's say we have 26/5. So this is an improper fraction, right? Can you convert it to a mixed number? Just like how we did here? C, right answer is C. Just like how we did here, right? So you divide 26 by 5, you will have a remainder of 1 this time instead of 2, right? And then quotient will be 5. Your quotient will be the new whole number, right? And denominator still remains same, which is exactly the divisor, okay? And the remainder becomes your numerator. So the right answer is C. Let's look at another example. Now this is again a improper fraction, right? An improper fraction. Can you convert it back to, I'm sorry. Yeah, this is an improper fraction. Can you convert it to mixed number, right? Can you do it? Somebody said D. Okay. Because you divide 17 by 4, right? You divide 17 by 4. You are dividing 17 by 4, so 4 times 4 is 16. Remainder is 1, so it will be 4, 1 over 4, right? This one goes here, this 4 goes here, and the quotient is actually the whole number. So the right answer is D. Now we have a mixed number, 3 5/8. Can we convert to this to an improper fraction? What is the answer? How do we do it? We just multiply 3 times 8, right? Plus 5, right? Whole number times denominator plus numerator. That makes it 29, right? But my denominator still remains same. It's 29/8, which is C. Let's look at another example. This is a mixed number. Can we convert it back to an improper fraction? A. 3 times 5 is what? 15. Plus 2 is 17, right? So 17 is going to be your new numerator, but the denominator remains same, right? So it's 17/3, which is A. Okay. Now, as I said before, that several fractions that look different, but they are exactly the same. To understand this, we will now try to find the equivalent fractions and show you how different fractions are actually equivalent. Now, look at this example here. We have, let's say, 1/3. If you multiply the both numerator and denominator by the same number, like this one here, let's say I multiplied the numerator by 4, denominator by 4, and then I got 4 over 12. This is exactly the same fraction. And similarly, if I divide the denominator and numerator by the same number, like here, let's say I divided both by 3, so I got 12 by 15, 12 over 15, I got it from there, I got 4 over 5. They are actually the same fractions. Okay? That means if you divide or if you multiply the numerator and denominator by the same number, then it becomes a different fraction, but still that is the same fraction. Okay? But it's a bit confusing now, because even if we do that, sometimes just by looking at that, we don't know exactly which one is equivalent to what, right? So to get there, we can always reduce the fraction to the lowest term. Meaning, if we are given multiple fractions, you can always find the lowest term, and lowest term will be exactly the same one which cannot be reduced further. And if they're equivalent, the lowest term will be same. And that's how you will know whether two fractions are equivalent or not. Okay? Even if they don't look same at the beginning. Now to do that, we first have to know the factoring of a number. Now what exactly is the factoring? Factoring means given any number, you should be able to write that number as a multiplication of several prime numbers. Now what is prime number again? There are some numbers we have in our number list. Those cannot be divided by anything except 1. For an example, 3. Can you divide 3 by anything to get another whole number? You cannot divide 3, right? I'm saying you can, but if you divide 3 by anything, you cannot get a whole number, right? 3 divided by 2, it will be 1.5, right? So, or you can always divide 3 by 3, but nothing else, right? Similarly, can you divide 5? No. 7? No. 11? No. 13? You see, there are plenty of these, right? 19? Right? So there are plenty of such number, like 23. There are plenty of such number which you cannot divide by any other number except that number itself and get a whole number. These numbers are called prime numbers. So the idea is, whatever the number you are given, you will basically write that number as a multiplication of other numbers, like this one. Let's say for an example, 6. You can write 6 as 1 times 2 times 3. Now what I'm using to write 6, I'm writing it as 1, 2, and 3. Look at this. 1 is, again, a prime number in some sense. 2 is a prime number. 3 is a prime number. So here, even if you look at the 12, you first wrote it at 4 times 3, and then again you divide 2 into 2. So at the end you have 2 times 2 times 3. All of these are prime numbers, right? 2 and 3. So that's how you can always write any number as a multiple factors. These are called factors, meaning for an example, 12, your factors are 2, 2, and 3. Okay? Any number you can write it as a factors of multiple prime numbers. Okay? Now this is important here because if you know these, then it will be easy for you to get the lowest term. Okay? Again, this is about the prime numbers, the prime factors. Now, how do I reduce any number to a lowest term? Before I do that, I have to always first get the prime numbers of of any number. How can I find it? Let's try some examples. Now let's say we have 36. How can you find the prime numbers of 36? What is prime numbers of 36? Can you find it from the list? Okay, if I write 36, I can start with 6 times 6. Now first of all, none of these are prime numbers, right? Because 6 can be divided by 2, get a 3, right? So I can write 6 as 2 times 3. I can write the next 6 as 2 times 3, and I can always write a 1. I'm saying 1 is like an optional, but it's sometimes it's required because if you cancel out everything in the in some process, you'll be left with only one that you need. So just we keep one always just as a, you know, but you know, it's not harmful because you can just keep it always, right? Anything multiplied by 1 is itself, so it doesn't matter. So 2 times 2 times 2 times, I'm saying 2 times 2 times 3 times 3 times 1, which is the D here, okay? That is your prime factors for 36, right? We just want to make sure that we understand that every number can be written as multiplication of prime factors, right? Meaning as a product of prime factors. Let's try another one. How about this one? 42. What is the prime factor for 42? Okay, you can also do a different sort of, you know, calculations like this one. For an example, let's say if you look at D, this is not prime factors because 6 is not prime, right? So you can rule this out. If you look at this one, 4 is not prime, right? Because you can divide 4 by 2, you can get 2 times 2, right? 14 is not prime as well. Because you can divide 14 by 2, right? And get a whole number, which is 7. How about the first one? This is actually the prime factors for 42. 7 times 2 times 3 times 1. You see? So, you know, we can get the prime factors in different manner. Now, let's look at how we reduce any fraction. Let's say we are given a fraction. Now, we are trying to get the lowest term for the fraction. And always we try to write the lowest term because otherwise, you can write a fraction, I can write a fraction, they're equivalent, but they will not look like they're equivalent. But if you write the lowest term, because there will be only one single lowest term for every fraction, no matter what I write and you write, okay? So if you write it in lowest term and if I write it in lowest term, that means it cannot be, you know, reduce it further, then if they're equal, you'll see it right away. Now let's see how we do it. Now let's say I'm given a fraction here, okay? Which is 16 over 24. All I need to do is I have to write the prime factors for 16 at the top because this is numerator, right? And prime factor of 24 at the bottom. And then I'll cancel out as much as I possible, okay? So look at this. I'm canceling all the 2's at the bottom and 3 2's from the top, meaning as many 2's as many common numbers as I can. So again, 16 over 24. So I wrote the prime factors of 16, which is 2 times 2 times 2 times 2. I can keep a 1. That's an optional 1. And 24, I can write 2 times 2 times 2 times 3. I can again keep a 1. And then I'm trying to cancel 1 if I get any common, right? I'm canceling the common ones. And then I'll be left with what? 2 over 3, right? And that is called the reduced term. Okay, reduced fraction, lowest terms of any fraction. And that's the lowest you can get from here. You cannot, you know, I'm saying you cannot get it further, you know, prime factors and cancel out. This is the best you can. Okay? Let's look at some example whether we can try these and see whether we understand it. How about 12 over 36? Let me give a pause so that you can try and see whether we can get an answer. Okay, what is the answer again? C? Everyone get C? Now, I know that some of you can get C very easily, but let me, because since we are trying to get the prime factors and cancel out, sometimes it's important to understand how we get these, even if we know the answer. So 12 over 36, if you do the prime factors, what is the prime factor of 12? Think about 12. 12 is what? 4 times 3, you can write 2 times 2 times 3, right? So that's 2 times 2 times 3 times 1. And 36 is what? If you write 36, you can start from 6 times 6, 2 times 3 times 2 times 3 times 1, right? You can always write 1 anywhere, right? So 2 times 3 times 2 times 3 times 1. So you cancel out. So you'll be left with 1 over 3, right? I know that sometime you might say, oh, it's just 12, right? Because, 12 times 36, 3 is 36. So let's cancel out. But it's not always easy like this, if you have a bigger fraction. So it's always better to get the prime factors and cancel out and see what you are left with, okay? So the right answer is C. Let's look at another example, 15 over 25. What is the right answer here? Three over 5? Everybody got the same answer? If I do this, 15 over 25, how do I write the prime factor? Fifteen is what? 5 times 3 times 1. 25. 5 times 1. Then I cancel out 5s. I'll be left with 3 over 5, right? That's how the right answer is B, which is 3 over 5. Any question here? Now we look at how we add the fractions. Okay. Now for an example, we are given 2 fractions. How we can add them? Now to add the fraction, you have to always make the denominator same. Now for an example, let's say you are adding these 2 fractions, okay? Now what is the problem here? The problem is the denominator of the first one is 4 and the denominator of the second fraction is 8. But to add them, you have to make the denominators exactly same. How can you make it same? Remember I said at some point that you can multiply the same fraction, you can multiply the denominator and numerator by the same number and it will still remain same, right? Okay. So what I can do is I can multiply both numerator and denominator here by 2 to make it 8 and to make it 6. The reason is because I want it as 8, right? So that both of the denominators get same. Now this, once I do that, I can write 3 over 4 as 6 over 8, right? So I just multiplied 3 by 2 to make it 6, multiplied 4 times 2 to make it 8. Now it's easy for me because both of my denominators are same. Now once the denominators are same, all I do is I add the numerators, which is 6 plus 3 is 9. Now this is actually my answer, 9 over 8, but this is an improper fraction. Now if I want, I get a mixed number. Now in pause, when you answer such questions, look at the answer. In some cases we gave you the answer as improper fraction. In that case your answer will be 9 over 8. But if you are given the answer as mixed number, then you still have to convert the number into mixed number, which will be 1 over 1, 1 over 8. You see what I'm saying? I'm saying, look at the question because it might be a multiple choice and you'll see how the answers are given. Similar is for the subtraction. If you want to do a subtraction again, you have to make the denominator same. Now remember, if the denominators is already same, you just do the subtraction. If they are not same, you have to make it same. Now how they become same? For an example here, you multiply 4 by 2, right? 4 times 2. Similarly, remember, you cannot only multiply the denominator. If you multiply, you have to multiply the denominator and numerator both by the same number. Okay? If I do that, this becomes 6 over 8, and I only subtract the numerators, meaning the second numerator from the first one, which makes it 3 over 8, because the denominator remains same, right, in both in addition and subtraction. Now let's look at a couple of examples here. How can I add half plus 1 over 4? Half plus 1 over 4. I have to make the numerator same, right? I have to make my numerator same. So the numerator in the first number is actually half, 2, right? Second number is 4, so I can write it as the first number. If I want to make the denominator same, meaning I have to multiply both by 2, right? That becomes 2 over 4. And the second number is 1 over 4. Now my denominators are same, and I'll be only adding these two numbers, which makes it 3. It's 3 over 4. Okay? So I actually multiplied both of these by 2. I can always do that. Just multiply both of the numerator and denominator by the same number. It will still remain the same fraction. Okay? So the right answer is C. Any question here? No? Let's try another one. 1 over 3 plus 5 over 6. One over 3 by 5 over 6. I'm writing 1 over 3 as 2 over 6, right? And we have 5 over 6. If you add, that becomes 7 over 6, right? Now remember, you can also write 7 over 6 as 1 over 6, right, as a mixed number. Now look at the answer in the pause and see how the answers are given, okay? Let's look at some subtractions. It's pretty much similar idea. Subtraction is same also because you just, but here you don't have to do anything because your denominator are same. All you have to do is just subtract the numerators, right? So it will be 5 over 5, which is actually 1. Because you subtract 7 minus 2, that becomes 5. So 5 over 5, which you can also write as 1. So right answer is A. Let's look at another example here. 7 over 15 minus 2 by 5. How can I do this? Yeah, sure. It's probably D, but let's check. So 7 over 15 minus 2 by 5. Now remember, I have to make the denominator same. To do this, I can multiply by 3 for both numerators and denominators for the second fraction, right? That's how it becomes 7 by 15 minus 6 by 15. And you will be left with 1 over 15, right? So the right answer is D here. Let's look at how we do the multiplication for the fractions. Multiplication is actually easy because, for an example, let's say you have, you have to be careful. If you have a mixed number, convert it to an improper fraction. Once you do it, all you need to do is just multiply the denominators and multiply the numerators. Here, if you multiply the numerators, that becomes 33. And if you multiply the denominators, 4 and 8, you get 32. So this is actually your answer. But if you want it as a mixed number, so you can convert it to the mixed number. Okay? Multiplication is actually easy. Okay? How do we go to division? Division is also easy, but there is a little trick. Let's say you do a division. You first get rid of the mixed number. You got the improper fraction. But you switch the sign, division, to multiplication, and you flip the second number, second fraction. Now how we do it? Look at this one. The second fraction you have is actually 11 over 8, right? But you switch the division into multiplication, and you flip this one. You made it 8 over 11 instead of 11 over 8. Basically, you just switch the numerator and denominator for the second fraction, for the second one. Do you see it? It was actually 11 by 8, and you change it to 8 over 11. Okay? And then the rest is multiplication. You just flip this one. Okay? Once you do it, the second number, all you do is just multiplication. So division is actually a multiplication. Okay? You just change this, sign operator from division to multiplication, and you flip the second number, and then rest is multiplication. And once you are done with multiplication, whatever you get, you always, go to the reduced term, right? Because sometimes, if the answer is not given as reduced term, answer is given as reduced term, you always have to go to the reduced term, right? Meaning the lowest term. So here is 2 over 44. So we just, wrote the prime factors for both, right? We know how to get there. We get there, right? 24 over 44, you can always write how? 2 times 3 times 2 times 2, right? That's 24. And 44, you can write 11 times 2 times 2. Then you cancel whatever you can. 6 over 11, right? That's how we get the reduced term. Remember, almost all of the time we want the lowest term or the reduced term, okay, for the fraction in the answer, if it is possible. That means if it is not in the lowest term, we always get to the lowest term, okay? Let's look at a couple of examples. It's a multiplication, right? Which is easy, so we just do 3 times 5, which is 15, and 6 times 7, which is 42. So the answer is 15 by 15 over 42, but we always want to double check whether that can be, that can be written as any lowest term. Is it possible? It's 15 over 42. I think this is possible, right? You can always write it as B, 5 over 14. (15 over 42). You always want to write it as a prime factor, right? 5 times 2, and then here 7 times 2 is 14 times 3. And then you cancel out 5 over 14, right? So actually A is a good answer, but the best answer is B. So you actually have to choose B, right? Let's try another multiplication here. So 2 times 6 is what? 12. And 8 times 9 is 72. So you get 12 over 72. Can you reduce it to the lowest term? (12 over 72), right? That's what we got. We of course can. I think we can write 2 times 3 for 12. For 72, we can write 2 times 2 times 2 times 2 times 3. I think you can start like very simple. For 72, you first can write 6 times 12, and then you can try 6 as 2 times 3, right? For 12, you can write 4 times 3, but you're not done yet, so you can write 2 times 2, because you can write 4 as 2 times 2. Okay? Then you can write all of these, and then you can cancel out. And then you'll be left with 2 at the top. And, I think 1 over 6, right? Because we can always write a 1 here, right? So 1 over 6 is your answer when you reduce it to the lowest term. So the right answer is C. So make sure, for an example, this one, D is a good answer, but the best answer is actually C. So you have to choose C, since you have the best answer here. Now let's look at a couple of division. Division is just a multiplication, right? If you flip the second number, see, it's 2 over 9 divided by 2 over 6. Okay, how do you do it? 2 over 9 divided 2 over 6. 2 over 6. So you write 2 over 9 multiplication 6 over 2. Yeah, I flipped it, right? Okay. So now I'm multiplying, which makes it 12 over 18. Then I'll again get to the reduced term just to see whether we can get a lowest term. Let's see whether we can cancel. We have a factor 2 times 2 times 3 at the top, and we have a factor 2 times 3 times 3 at the bottom. We cancel out everything. We'll be left with 2 over 3. So the right answer is A, right? Right answer is A. Any question here? Let's look at some more divisions. How about this one? 7 over 18 division 14 over 24. Seven over 8, not 18, I'm sorry, 7 over 8. So you do the division, you start with 7 over 8, and then you put a multiplication sign, and you flip the second number to 24 over 14, right? Now, a lot of times people do like this. Instead of multiplying, they try to see whether they get a factor here, and then cancel out, and then at the last they multiply. That's another way of doing it. Let's make it a little bit simpler, because if you multiply, the numbers get bigger and the factors will be more and more. It's hard to find the factors sometimes. So for an example, 7 is already a prime number. You don't have to care about 7. 8 you can write 2 times 2 times 2. Okay, now let's check whether we can write factor for 24, which is 2 times 3 times 2 times 2, right? And 14 we can write 7 times 2. Now let's see whether we can cancel here. I'm saying before we multiply, we just get the factors and we see whether we can cancel out, and then at last we multiply. So 7 we can cancel. Let's see. I think we can cancel. We'll be able to cancel a lot of numbers. 2 to 2. So we are left with 3 at the top and 2 at the bottom. You see it? Now we see how small the fraction is, right? It's only 3 over 2. But it's sometimes better before you multiply, you just get the factor, cancel out everything, and then you multiply. Okay? So the right answer is here 3 over 2, and also you can write 1/2. Now I'm not sure how the answer will be given, but in pause you probably will be given one of these, not both, because it's C and D both are the right answer, depending on how you want the answer, either in fraction. I'm saying, yeah, but even if you get the lowest term, you can still convert it back to the mixed number, right? It doesn't matter, right? The lowest term is also equivalent to a mixed number. So the final summary is this. If you have an addition and subtraction, you always find a common denominator and then add the numerators or subtract the numerators. You keep the denominator same. Okay? And in case of multiplication division, you always change the mixed number to improper fraction. And in case of division, you invert and multiply. You have to flip, right? Second number, that is basically the inverting. And then you always factor, cancel, multiply numerators, multiply denominators, right? But at the end, you always get back to the lowest term. Okay? This is like a summary of all the 4 operations: subtract, addition, subtraction, multiplication and division for fractions. Now let's go to the quiz section. In pause, we have, I think, several part of this quiz for this chapter, which is actually chapter 2. So let's go to the quiz section and let's finish all the quizzes for this chapter. Okay.